Let me take a few minutes and just mention some things about the quiz that was returned to you. So it doesn't matter whether you're doing a two-sample situation regarding means or proportions. You need two independent random samples. You could have said random independent samples. That would be fine. That's 1 point each. So question number 2. For all of these questions, actually, the test name is worth 2 points. The null and alternative hypothesis are also worth 2 points each. So this is a question about proportions. So this is a two-proportion z-test. Some people said a two-sample z-test. I didn't take off for that, but be careful. A two-sample z-test suggests that you are working with means, but that you can use z-scores because you know the population standard deviations. And that's not what's going on here. We can use z-scores because we're working with proportions. You really should call it a two-proportion z-test. So that means your null hypothesis involves proportions, proportion of seniors equal to the proportion of juniors. The null hypothesis is always the equal to alternative. The alternative hypothesis, then, the question states seniors being greater than the proportion of juniors that text during class. So you could write that as proportion senior greater than proportion junior. You could write proportion junior less than proportion senior. You could write it as a difference greater than 0 or a difference less than 0, depending on the order in which you write the proportions. There are multiple answers that are possible. So question 3 then is about the normality condition for a two-proportion z-test. So you want all of your counts to be greater than a boundary, say 5 or 10. So we have 26 juniors that do and 14 that don't text during class. So that's fine. The problem is the seniors. 37 out of the 40 say they do. Only 3 say they don't text during class. So those are not all greater than or equal to 10 or all greater than or equal to either of our boundaries, 10 or 5. So in this case, the normality condition is not met. That's the condition for a two-proportion z-test. So question number 4 is about a two-sample t-test. So 2 samples, it's a t-test because we're dealing with means. So this is a difference question. So the alternative hypothesis is the not equal to hypothesis. Null is always the equal to hypothesis. Probably the most common thing that was missed on question number 5, when you're working with means. When you're working with means, you're interested in discussing the central limit theorem when it comes to normality. But here, it's not the individual sample sizes, it's the combined sample size. So this question suggested that both of the sample sizes are 40, so the combined sample size of 80 is greater than 30. And because of that, the central limit theorem applies, and you can say that the sampling distribution is approximately normal. Question 6 is a one-proportion z-test, so you only had to work with the proportion of seniors, and this time we're comparing it to a specific value, 0.65. So, and it said fewer, so the alternative hypothesis should be a less than alternative, proportion seniors less than 0.65. Question 7a then, what's very important, our most important condition is that our samples are random. The question says one teacher decides to interview the 30 seniors in their classes, but that's not a random sample. That's a convenience sample. The problem isn't the size 30, the problem is that we don't have randomness here. They need to use a random sample. Plus, if they're really interested in evidence of the size of the problem, well, at that situation then, a significance test isn't as helpful as a confidence interval. If you want an idea of the size or the magnitude of an effect, you want to build a confidence interval, not a significance test.